Let us begin today with work energy principles. So all of you, I'm sure that you know what is work done by a force. Vedan, can you tell me how do you define work done by a force?
Sir, the displacement done by the object when force is applied.
Yes, to be precise, work done by a force is given as that magnitude of that force multiplied by the displacement in the direction of the force. If the displacement occurs in the direction of the force, we say the work is done by the force and we treat it as positive. Are you with me?
Yes, sir.
However, if the displacement occurs contrary to the force applied, then we say that the work is done on the force and we treat it as negative. Are you with me?
Yes, sir.
So typically what we understand or how do we write work done by a force? It is force magnitude of force multiplied by the displacement that has occurred in the direction of force. Happy?
Yes, sir.
Okay. So all of us, we are aware of these concepts in 11th and 12th standard physics. Let's take those concepts ahead. Now, if you look at the arrangement that I have shown here, there is a spring to which a block of mass m is attached. Are you with me?
Yes, sir.
So this is the block of mass m. Mass कितना है इस block का? M. Happy?
Yes, sir.
And this block, when the spring is unstretched, is at position number 1. Let us see. Are you with me?
Yes, sir.
Now, by some external agency or under its own weight, it has been taken to position number 2. Happy?
Yes, sir.
And we are asking a very particular question. What is the work done by gravitational force during this travel from position number 1 to 2? Are you with me?
Yes, sir.
So we have to write down work done by only gravitational force. This block is acted upon by many forces. For example, as the block moves from position number 1 to 2, there has to be some external force that does this movement, or it may occur under the self weight. Secondly, as it moves from position number 1 to 2, there is a spring force because spring is going to get elongated and therefore it is going to resist. Do you agree with me?
Yes, sir.
Then as the block moves from position number 1 to 2, there is also a frictional force because the block is resting on a rough surface. Are you with me?
Yes, sir.
So I will call this surface as rough one. So that means there is going to be friction as well. But right now I am interested only in finding out work done by, let us say, gravitational force as the block moves from position number 1 to position number 2. Are you with me?
Yes, sir.
Now, how does the block move from position number 1 to 2? There are two paths. In first path, it directly moves from 1 to 2. Are you with me?
Yes, sir.
And in the second path, it moves from position number 1 to position number 3 and comes back from position number 3 to position number 2. Are you with me?
Yes, sir.
Of course, there is going to be some external force that is deciding the path along which this block is going to move. But right now, I'm interested in work done by only gravitational force. Happy?
Yes, sir.
Now, what is the gravitational force acting on a block? Gravitational force acting on a block is mass into acceleration due to gravity, that is g, mg. Do you agree with me?
Yes, sir.
Okay. And let us say that from position number 1 to 2 along the inclined surface, distance traveled is delta 1. From position number 1 to 3 along the inclined surface, distance traveled is delta 2.
Yes, sir.
Whereas the vertical distance is h1 and h2. Of course, this h1 and h2 is going to be related to delta 1 and delta 2 through the angle of inclination theta. Happy?
Yes, sir.
That all is known. Now let me write down work done by only gravitational force when the object follows path 1 to 2. Happy?
Yes, sir.
So देखो denote कैसे किया है? Capital U is used for work done. G stands for work done only by gravitational force, and superscript 1 to 2 stands for work done by the gravitational force as the object follows the path 1 to 2. Happy?
Yes, sir.
So what is the force acting from 1 to 2? Gravitational force कितना है? Mg. And as the block moves from position number 1 to 2, what is the displacement that has occurred in the direction of the force? Delta 1 has occurred along the surface, inclined surface, but it is not in the direction of mg. Do you agree with me?
Yes, sir.
Its component will be in the direction of mg. And what's that component? That component is shown as h1. Do you agree with me?
Yes, sir.
And now mg is acting downwards and h1 also has occurred downwards while the block moves from 1 to 2. Therefore, work done by gravitational force in this movement from position number 1 to 2 will be treated as positive. Why positive? Because h1 is in the direction of mg. Do you agree with me?
Yes, sir.
So it is going to be plus mg h1. Happy?
Yes, sir.
Whether the block moves upward or downward has nothing to do with it, positive or negative side. You have to look for the force and the displacement that has occurred. If displacement occurs in the direction of the force, work done is positive. If displacement occurs against the direction of the force, work done is negative. Happy?
Yes, sir.
Okay. So path 1 to 2 was very easy. Now let us look at the second path. Now the object moves from position number 1 to position number 3. Happy?
Yes, sir.
And then from 3 to 2 it comes back to 2. So final position is same and initial position is same. Do you agree with me?
Yes, sir.
Final and initial positions are same as the earlier one, but the path followed is different. Happy?
Yes, sir.
Now how do I write down the work done by gravitational force when the object moves from position number 1 to 2 via path 1 3 2? So I will split this into two parts. It is work done by the gravitational force as the object moves from 1 to 3 plus work done by the gravitational force as the object moves from 3 to 2. Do you agree with me?
Yes, sir.
Now what is the work done by gravitational force as the object moves from 1 to 3? So as object moves from 1 to 3, inclined distance is delta 2, but that is not what I am interested in. In the direction of mg, what is the distance traveled? It is h2. Do you agree with me?
Yes, sir.
And is it in the direction of mg? Yes. So therefore work done will be positive. So work done by gravitational force in moving the object from 1 to 3 is plus mgh2. Do you agree with me?
Yes, sir.
And now the object is stretched back to 2. So from 3 it goes back to position number 2. During this its travel from 3 to 2, still the force acting on the body, gravitational force acting is same, mg. Do you agree with me?
Yes, sir.
But now it has traveled this much distance. And what is this distance? Tell me.
H2 minus H1.
This distance is h2 minus h1. Distance will be without any sign. Distance is h2 minus h1. But has this distance been traveled in the direction of mg or against the direction of mg?
Against.
Therefore, we are going to assign negative sign to the work done. Are you with me?
Yes, sir.
So as the block moves from 3 to 2, the work is done against the gravitational force. Are you with me?
Yes, sir.
And how much is that? mg h2 minus h1. Happy?
Yes, sir.
With negative sign. Agreed?
Yes, sir.
So now, what is the work done by gravitational force as the object moves from 1 to 3 to 2? So you will see that mgh2 is going to get cancelled and minus of minus will become plus and it will be mgh1. Do you agree with me?
Yes, sir.
Is it exactly the same as work done by gravitational force when it followed path 1 to 2?
Yes, sir.
Now you can prove that even if the object follows any path, it can go to the other end of universe and come back. But as long as it comes back to 2, the work done is going to be same by gravitational force, of course. Are you with me?
Yes, sir.
So such forces where work done by the forces depends only on the final and initial position and is independent of path, we call such forces as conservative forces. Kya bolenge?
Conservative forces.
Yes. So what do you understand by the word conservative? Tell me. इसका मीनिंग क्या है as per the English dictionary? Something that refuses to change. Do you agree with me?
Yes, sir.
So what is that something which refuses to change? The work done refuses to change with reference to the path. Do you agree with me?
Yes, sir.
As long as the initial and final position of the object is same, if the work done remains constant irrespective of the path followed by the object, then we call such forces as conservative forces. Happy?
Yes, sir.
Okay, we will do one more exercise. Now what we are going to do is we are going to now find out work done by gravitational force as the object moves from, let us say, 2 to 3. Are you with me?
Yes, sir.
So I think let us stick to the earlier sign convention. So G, let it be subscript and 2 to 3 be superscript. So now we are finding out work done by only gravitational force acting on a body when it moves from position number 2 to 3. Happy?
Yes, sir.
Now the work done will be positive because while moving from position number 2 to 3, it is moving in the direction of mg. Do you agree with me?
Yes, sir.
And what is the component of motion in the direction of mg? It is h2 minus h1. So the work done will be plus mg h2 minus h1. Do you agree with me?
Yes, sir.
So I will write this as mg h2 minus mg h1. And now comes the definition of potential energy. अब तक आपको ये सिखाया गया है कि potential energy is given as mgh. Do you agree with me?
Yes, sir.
But you have to understand, potential energy really doesn't have any physical significance, because if I change the reference, let us say I'm calculating a potential energy of a ball which I have, which is in my hands from the floor. तो वो कितना होगा? Probably it will be mg into height of my hand or height of my palm from the floor. Do you agree with me?
Yes, sir.
But if I have to now write down the potential energy with reference to ceiling, what it will be? It will, first of all, it will be minus because the ball is below the reference. Do you agree with me?
Yes, sir.
And it will be mg into some other distance. That distance will be from ceiling till my palm. Do you agree with me?
Yes, sir.
What I'm trying to say is this is the ball, this is the ceiling, and this is the floor level. Let us call this as h1 and let us call this as h2. Happy?
Yes, sir.
So now, if I'm calculating the potential energy of a ball with reference to this as a reference, floor as a reference, what is this potential energy? Plus mgh1. Do you agree with me?
Yes, sir.
If I'm calculating the potential energy with reference to another reference, what it is? Tell me.
Minus
Minus
mgh2.
mgh2. So if the quantity is changing, if you change the reference, अगर आपने ऑब्जर्वेशन अलग जगह से किया तो क्वांटिटी चेंज हो रही है, तो उसको कुछ फिजिकल मीनिंग होगा क्या? Are you with me?
Yes, sir.
There is no physical meaning associated with potential energy. Potential energy is convenience. And why do we toss in first place the term such as potential energy? क्योंकि देखो, have a look at this expression. UG, work done by gravitational force in moving the object from 2 to 3, is mgh2 minus mgh1, where h2 and h1 are measured with reference, h2 and h1 are measured with reference to what? Tell me. Yes, tell me. Veda?
Yes, sir.
H2 is measured with reference to this reference. Do you agree with me?
Yes, sir.
And H1 is also measured with reference to this reference. Do you agree with me?
Yes, sir.
Now, can I write down this expression slightly differently? Can I take a negative sign common? Are you with me?
Yes, sir.
And can I write it as, or 1 minute, can I write it as minus of minus mgh2? Happy?
Yes, sir.
And plus minus mgh1. Do you agree with me?
Yes, sir.
ऐसे भी लिख सकते हैं इस एक्सप्रेशन को.
Yes, sir.
Now, just have a look at the equation of potential energy that you are that you already know. How do we write the potential energy? if I have to write potential energy of the object at position number 2, how will I write? It is with reference to this reference, it is going to be minus mgh1. Do you agree with me?
Yes, sir.
So can I call this minus mgh1 as potential energy associated with gravitational force at position number 2?
Yes, sir.
So what is the symbol for potential energy? For potential energy, we use the symbol V2. V, sorry. Are you with me?
Yes, sir.
This is the potential energy associated with the object at position number 2. And this potential energy is defined as far as gravitational force is concerned. Do you agree with me?
Yes, sir.
तो ये जो वर्क डन का एक्सप्रेशन है उसके तरफ देख के हमने डिसाइड किया कि mgh करके जो क्वांटिटी है उसको हम पोटेंशियल एनर्जी बोलेंगे. Are you with me?
Yes, sir.
We also decided the sign convention. अगर ऑब्जेक्ट रेफरेंस के नीचे है तो हम उस पोटेंशियल एनर्जी को नेगेटिव बोलेंगे. Are you with me?
Yes, sir.
और अगर ऑब्जेक्ट गिवन रेफरेंस के ऊपर है तो उसको हम पॉजिटिव बोलेंगे एज फार एज ग्रेविटेशनल पोटेंशियल एनर्जी इज कंसर्न. आर यू विथ मी?
Yes, sir.
So therefore we define something called as mgh function as potential energy associated with gravitational force. Are you with me?
Yes, sir.
And h will be positive if above the reference. Happy?
Yes, sir.
And h will be negative if below the reference. Are you with me?
Yes, sir.
Mind you, now to define potential energy, it was absolutely necessary that the force for which you are defining the potential energy has to be conservative. समझ में आ रहा है?
Yes, sir.
क्यों? क्योंकि मेरा एम ये नहीं है कि पोटेंशियल एनर्जी लिखना. मेरा एम ये है while the object moves from one position to other, what is the work done by that force? That work done can be expressed in terms of potential energy at final position and potential energy at initial position. What is the potential energy at initial position? Object has moved from point number 1 to point number 2. Are you with me?
Yes, sir.
What is the potential energy associated with position number object has moved from position number 2 to position number 3. What is the potential energy associated with position number 3 now? Tell me.
H2 minus.
mgh2 minus mgh2. So is it v3?
Yes, sir.
Do you agree with me? And minus sign is sitting there. Happy?
Yes, sir.
So what is the expression? I get an interesting expression. What is the work done by gravitational force when the object moves from 2 to 3? Tell me. It is v2 minus v3. Do you agree with me?
Yes, sir.
And this potential energy is as far as gravitational force is concerned. So I am going to write G as a superscript. Are you with me?
Yes, sir.
When I write G as a superscript, what is the expression for potential energy? mgh. What is the sign convention? H is positive when it is above the reference. H is negative when the object is below the reference. Do you agree with me?
Yes, sir.
This expression holds good even if you change the reference. You can cross verify that. You can say that this is my reference and still you will be able to get the same expression. The work done by gravitational force as the object moves from 2 to 3 is potential energy associated with gravitational force at 2 minus potential energy associated with gravitational force at 3. Are you with me?
Yes, sir.
Change in potential energy has a physical meaning. What is the meaning? It is work done by gravitational force. But the potential energy in itself doesn't have any physical meaning, because if I change the reference, its magnitude is going to change, its sign is going to change. Do you agree with me?
Yes, sir.
Okay. So that's how we define potential energy. It is defined only to write down the work done by a particular force in moving the object from one place to another. The potential energy is defined for conservative force. The expression of potential energy will change if you change the conservative force. Are you with me?
Yes, sir.
So mgh ये expression किसके लिए है? Gravitational potential energy के लिए. Are you with me? So it is
Yes, sir.
only the expression for gravitational potential energy, not for other forces. Happy?
Yes, sir.
Let us cross verify this in situation number 1. What is the work done by the object when when the object moves from 1 to 2 via path 1? Can you tell me that? So
MGH.
UG 1 to 2. It is potential energy at 1. Happy?
Yes, sir.
Minus potential energy at 2. Do you agree with me?
Yes, sir.
What is potential energy at 1? Tell me. Potential
Zero.
energy at 1 is 0 because H is 0. Do you agree with me?
Yes, sir.
0. Minus. What is potential energy at 2?
Minus MGH1.
Yes. So I will write it as minus mgh1. Why? Because h1 is below the reference. So minus of minus becomes plus and you will get it as mgh1. Happy?
Yes, sir.
So I have just proved that this is valid everywhere. And mind you, this UG1 to 2 is independent of path. Let it follow any path. It is going to be equal to V1 minus V2, V1G minus V2G. Are you with me?
Yes, sir.
So this was about the gravitational potential energy and work done by gravitational force and conservative nature of gravitational force. Now let us ask ourselves a question. What is the work done by spring force as the object moves from 1 to 2 via these two paths? Are you with me?
Yes, sir.
So let us now look at spring force. So I'm going to call it as work done by spring is elastic. Are you with me? We are
Yes, sir.
dealing with elastic forces or elastic springs. There, that means if you deform it and leave it, it will regain its original shape and size. That's the spring that we are talking about in this introductory course of mechanics. Are you with me?
Yes, sir.
So work done by the spring force, I am going to call it as UE. E stands for elastic force. Are you with me?
Yes, sir.
So it is work done by spring force. Happy? Which is elastic. Happy?
Yes, sir.
Okay. Now we are going to not look at all the other forces acting on a body. We are going to only look at the spring force. Happy?
Yes, sir.
Chalo. So let's try and write down this work done. So for path number 1, I'm going to do it for path number 1. So what is path number 1? Path 1,
Two,
it is going to be 1 to 2
two.
directly. Happy?
Yes, sir.
So when spring is unstretched, it is at position number 1. Happy?
Yes, sir.
And when the spring is stretched, it has gone to position number 2. Happy?
Yes, sir.
So what is the stretch in spring? This spring is now stretched by amount delta 1. Do you agree with me?
Yes, sir.
Because this distance is how much? Let me show that distance here. That distance by which the spring is stretched is delta 1. Do you agree with me?
Yes, sir.
देखो यहाँ पे delta 1 से stretch हुआ है to reach position number 2. Happy?
Yes, sir.
Now, I'm going to ask you the question. When the spring is at position number 1, when the spring is at position number 1, what is the stretch in the spring? Can you tell me? What is the stretch in the spring? 0. Because when it is at position number 1, this is unstretched.
Yes, sir.
Unstretched. Happy?
Yes, sir.
And now, as the object moves from 1 to 2, will the spring force remain constant or will it change? Spring stiffness is K. What is spring stiffness? Spring stiffness K is force required for unit deformation. Are you with me?
Yes, sir.
For unit deformation. So if the deformation is unity, the force required to cause that deformation, that is force in the spring, will be K. Are you with me?
Yes, sir.
But as the deformation goes on increasing from 1 to 2, this spring force is not going to remain constant. Do you agree with me?
Yes, sir.
So what I am going to do is, at distance x from this position, at distance x from this position, I am going to consider a small travel of this object from x to x plus dx. Are you with me?
Yes, sir.
Dx is so small such that over which I can assume that the deformation of the spring or stretch in the spring is x itself. Happy?
Yes, sir.
So what is the force in spring during this travel of the object from x to x plus delta x? देखो x to x plus delta x ये travel है. Are you with me?
Yes, sir.
So at that time, what is the spring force? Is it kx? Yes, because initially the deformation was 0. Now the deformation is x, and force required per unit deformation is k. So therefore, what is this spring force? It is k times x. Do you agree with me?
Yes, sir.
Okay. Now, what is the work done by this spring force as the object moves from x to x plus dx? ये लिखते हैं. Work done by spring force as the object moves from x to x plus dx. Happy?
Yes, sir.
Will it be spring force kx multiplied by dx? देखो स्प्रिंग फोर्स के डायरेक्शन में कितना गया है ये ऑब्जेक्ट dx अमाउंट से गया है, बट spring will be pulling this object back. Do you agree with me?
Yes, sir.
So ये kx है, and the deformation that has occurred is against the kx. So can I call it as minus kx dx?
Yes, sir.
Have you understood this? I will explain once again. Let us say the object is occupying position x and it goes to x plus dx. So it moves in positive x direction. However, during this travel, the spring force was kx and that was trying to pull back the block. Do you agree with me?
Yes, sir.
So therefore, work done is minus kx dx. Dx is so small such that over which I can assume kx is going to remain constant. Happy?
Yes, sir.
Now, what is the work done by elastic force in moving the object from position number 1 to 2? Tell me. This will be integration of work done in moving the object from x to x plus dx. Do you agree with me?
Yes, sir.
Integration कहां से कहां तक? From x is equal to 0. Are you with me?
Yes, sir.
To x is equal to delta 1. Do you agree with me?
Yes, sir.
So at position number 1, what was the deformation of spring 0? At position number 2, what was the deformation of spring delta 1? Happy?
Yes, sir.
So how much it is? Tell me quickly. What should I write this as?
Minus kx square by 2 from
Minus
0
kx dx integration from 0 to delta.
to
Now instead of calling it as 0, what I will say is deformation of spring. Deformation, deformation of spring at 1. Let us call it as x1. Happy?
Yes, sir.
And we know that deformation x1 is 0 here. This we know. Happy?
Yes, sir.
So x1 is not the position of the block. It is the deformation or stretch in the spring that you have to understand. Are you with me?
Yes, sir.
And now tell me, what is the deformation of spring? Deformation of spring at 2. Tell me. I will call it as x2. X2 will be equal to delta 2 in our case. Do you agree with me?
Yes, sir.
Chalo. So therefore, I am going to now integrate from not delta 2, delta 1.
Delta. Yes, sir.
Chalo. Now I am going to integrate from x1 to x2 so that I arrive at the generalized expression. It is not necessary that we will like to have work done by the spring force when the spring was originally unstretched. ऐसे भी तो हो सकता है कि हमें work done चाहिए from 2 to 3. In that case, the spring will originally be not unstretched. Do you agree with me?
Yes, sir.
Okay. So therefore, I am going to call it as x1 to x2 instead of calling it as 0 to delta 1. Are you with me?
Yes, sir.
In this particular case, we know x1 is 0 and x2 is delta 1. But I have to arrive at the generalized expression. Do you agree with me?
Yes, sir.
Chalo. So how much is that? Tell me.
Minus kx square by 2 where
Minus
kx square by 2.
kx square by 2 where I have to put this as x1 and x2. Happy?
Yes, sir.
So is it minus kx 2 square by 2 plus kx1 square by 2?
Yes, sir.
तो अब जरा यहाँ पे ध्यान दो. I am going to call this as kx1 square by 2 minus kx2 square by 2. Happy?
Yes, sir.
This is work done by elastic force in moving the object from 1 to 2. Happy?
Yes, sir.
Okay. Chalo. Now let us follow via path 1. Now let us look at path 2. What is the path 2? Tell me. Object moves from 1 to 3 and comes back to 2. Do you agree with me?
Yes, sir.
Now, so work done by elastic force or spring force when the object moves from 1 to 3 and comes back to 2 is going to be equal to work done by elastic force as the object moves from 1 to 3. Happy?
Yes, sir.
Plus work done by elastic force when object moves from
2 to 3. 2 to 3. 2 to
3 to 2. Do you agree with me?
Yes, sir.
Chalo. Now, what is the work done by elastic force when object moves from 1 to 2? It is kx1 square by 2 minus kx2 square by 2, where x1 and x2 are stretches in the object at position number 1 and 2. We have stretches in spring at position number 1 and 2. Do you agree with me?
Yes, sir.
So, if I derive the similar expression for work done by elastic force in moving the object from 1 to 3, what will I get? I will get it as k x1 square by 2 minus k x3 square by 2. Do you agree with me?
Yes, sir.
This is the first term. Plus, now I am writing down the expression from 3 to 2, work done by elastic force in moving the object from 3 to 2. So it will be k x3 square by 2 minus k x1 square by 2. Do you agree with me?
Yes, sir.
So can I write it as k x3 square by 2 minus k x2 square by 2? Do you agree with me?
Yes, sir.
And now what is the result that you get? This is equal to x3 square by 2 and x3 square by 2. They are going to get cancelled and you will get it as k x1 square by 2 minus k x2 square by 2. Do you agree with me?
Yes, sir.
This is work done by the elastic force via path 2 as it moves from position number 1 to 2, but via path 2. Via path 2. Is it same as the earlier one? Are these
Yes.
two same?
Yes, sir.
So what can you say about the spring force? Is it conservative or non-conservative?
Conservative.
Yes. So therefore, even spring force is or elastic force is going to be conservative in nature. Happy?
Yes, sir.
Great. So as long as it is conservative in nature, I am going to express the expression for its potential energy. Do you agree with me?
Yes, sir.
So what should be the expression for potential energy due to elastic force. देखो, as per the earlier equation, we know that work done by gravitational force in moving the body from 2 to 3 is potential energy associated with gravitational force at 2 minus potential energy associated with gravitational force at 3. Do you agree with me?
Yes, sir.
So on same line, if I have to say the work done by elastic force in moving the object from 1 to 2 is equal to potential energy due to elastic force at 1 minus potential energy of due to elastic force at 2. Do you agree with me?
Yes,
ये
sir.
अगर लिखना है, so what should be the expression for potential energy of elastic force? It must be kx square by 2. Do you agree with me?
Yes, sir.
Are you with me?
Yes, sir.
So this is the expression for elastic force, potential energy associated with elastic force. And what is x? X is deformation of the spring. Happy?
Yes, sir.
It will be positive if it is extension. Are you with me?
Yes, sir.
And it will be negative if it is contraction. Are you with me?
Yes, sir.
But irrespective of whether it is contraction or extension, as there is x square sitting here, the sign is really not going to matter. Are you with me?
Yes, sir.
Unlike the unlike the potential energy for gravitational force, their sign is going to matter. Happy?
Yes, sir.
So we have now dealt with two conservative forces. कौन से? एक gravitational force और दूसरा कौन सा है?
Elastic.
Elastic force. What is the expression for potential energy in case of gravitational force? mgh.
mgh.
What is the sign convention? H is positive if it is above the reference, H is negative if it is below the reference. What is the potential energy expression for elastic force? It is kx square by 2, where x is the deformation in the spring. Happy?
Yes, sir.
What is the sign convention? X is positive if extension, X is negative if it is contraction. But as there is x square in the expression of potential energy associated with elastic force, the sign is not really going to matter. It is going to matter for gravitational force. Happy?
Yes, sir.
And what is one more principle that we have derived? As long as it is a conservative force, work done by that force. So I will now write down the work done by any conservative force in general. Are you with me?
Yes, sir.
Any conservative force. This will be in moving the object from 1 to 2, position number 1 to 2, will depend only on its initial and final position, and it will be given as potential energy associated with that conservative force. Are you with me?
Yes, sir.
At position number 1 minus potential energy associated with same conservative force at position number 2. Happy?
Yes, sir.
The expression, the form of expression for potential energy will change depending upon the nature of conservative force. If it is gravitational, it is mgh. If it is elastic, it is half kx square. Happy?
Yes, sir.
Okay. So अब हमने तो अभी सिर्फ दो फोर्सेस देखे हैं, ऐसे और भी कई सारे कंजर्वेटिव फोर्सेस हो सकते हैं, उनके पोटेंशियल एनर्जी का एक्सप्रेशन अलग अलग होगा. Are you with me?
Yes, sir.
Okay. But in this course, we are going to deal with only these two conservative forces. कौन से? Gravitational and elastic. Happy?
Yes, sir.
Now we are going to close our discussion for today once we write down the work done against the friction. Are you with me?
Yes, sir.
So let us write down work done. Work done by frictional force. Happy?
Yes, sir.
Okay. So path 1. I am going to choose path 1. Happy?
Yes, sir.
And what is the path 1? The object moves from position number 1 to position number 2. Happy?
Yes, sir.
During its motion, now I am only interested in work done by the frictional force. So I am only going to show the frictional force. Happy?
Yes, sir.
So as object starts moving from position number 1 to position number 2, it must have broken the crest and trough bonds, and therefore it must be experiencing kinetic friction and not static friction. Are you with me?
Yes, sir.
So I am going to call this force as Fr kinetic, and it is going to remain fairly constant. We assume that this motion has occurred under the constant velocity. Are you with me?
Yes, sir.
So let us say this is the frictional force. Now can you tell me what is the work done as the object moves from position number 1 to 2 by the frictional force? This distance is delta 1. Happy?
Yes, sir.
So work done by frictional force Fr as the object moves from 1 to 2 via path 1 to 2. अरे we will maintain, ऐसे लिखा था ना हमने अब तक.
Yes, sir.
So let us maintain this thing. So here also I have to write, take this down, take this up. Are you with me?
Yes, sir.
Okay, great. So now tell me, what is the work done by friction? Frictional force is always against the movement. Do you agree with me?
Yes, sir.
This is the frictional force offered by ground on the block. So what is the work done? Tell me. Minus Frk. Do you agree with me?
Yes, sir.
Into delta 1. Happy?
Yes, sir.
Now let us look at work done by the frictional force via path 2. Path 2. Work done by frictional force in moving the object from 1 to 3 to 2 is work done by the frictional force in moving the object from 1 to 3 plus work done by frictional force in moving the object from 3 to 2. Do you agree with me?
Yes, sir.
1 to 3 is fairly easy. You have to just replace this 2 is by 3. Do you agree with me?
Yes,
So
sir.
the first term is going to be equal to minus Frk into delta 2. Do you agree with me?
Yes, sir.
What is this term now? Let us try and look at work done by the frictional force when the object moves from position number 3. This is position number 3 to position number 2. Are you with me?
Yes, sir.
Now object is moving in which direction? This direction. Do you agree with me?
Yes, sir.
So frictional force must be in which direction? This direction. Do you agree with me?
Yes, sir.
So what is the work done? Tell me. Delta 3 minus delta 2 is this distance.
Yes,
Do you
sir.
agree with me? Sorry, delta 2 minus delta 1 is this distance. Delta 2 minus delta 1. Do you agree with me?
Yes, sir.
And the work is done against the frictional force. So I have to assign negative sign because frictional force is down and the object is moving up. So isn't it Frk delta 2 minus delta 1?
Yes, sir.
So what is the total work done? Tell me.
For delta 1.
Minus 2 times Frk into delta 2. Happy?
Yes, sir.
My plus
Frk delta.
Frk into delta 1. Happy?
Yes, sir.
This is the work done by frictional force as the object moves from 1 to 3 to 2. Is it same as the work done by frictional force when object moves from 1 to 2? No.
No.
Do you agree with me?
Yes, sir.
So let me take this down. This is not equal to this. Happy?
Yes, sir.
So what can you say about frictional force? Is it a conservative force or
Non-conservative.
so it is non-conservative force, and the work done does not depend merely on initial and final position. It also depends upon the path followed.
Yes, sir.
Are you with me?
Yes, sir.
So I have made the point: frictional force is non-conservative in nature. Happy?
Yes, sir.
And can we write down the potential energy associated with frictional force then? No, there is no point. The whole idea of writing potential energy was to write down the work done by a particular force in moving the object from one place to other. समझ में आ रहा है?
Yes, sir.
अगर वो वर्क डन ही फाइनल और इनिशियल पोजीशंस पे डिपेंडेंट नहीं है तो पोटेंशियल एनर्जी लिख के उसके बारे में सोच के भी क्या फायदा? Are you with me?
Yes, sir.
So therefore, we do not define anything called as potential energy associated with non-conservative forces. Happy?
Yes, sir.
So let us summarize today's class and then we will stop here. What is the summary? We learned about what is conservative force and what is non-conservative force. Happy?
Yes, sir.
Conservative force is the force for which the work done in moving the object from position number 1 to 2 under that force does not depend upon the path followed. It depends only on initial and final position. Happy?
Yes, sir.
Elastic and gravitational forces are conservative in nature. However, friction is non-conservative force. The work done in moving the object from position number 1 to 2 does not merely depend upon the initial and final position. It also depends upon the path followed. Happy?
Yes, sir.
We define potential energy with conservative forces. We do not define potential energy associated with non-conservative forces. This is the next lesson. Are you with me?
Yes, sir.
And if the body is acted upon by conservative force, the work done can be written as potential energy associated with that conservative force in initial position minus potential energy associated with that conservative force in final position. Are you with me?
Yes, sir.
So that is the first work energy principle that we have learned today, and that is applicable only for conservative forces. This one. Happy?
Yes, sir.
Now we are going to learn another two principles tomorrow. One of that is related to conservative forces, applicable to only conservative forces, and another one is applicable to any general force system. Happy?
Yes, sir.
So with this, we are going to close the class. Ask me if there are any doubts. I'm going to stop the recording.